next speaker, coming from Malaysia this time, to share the experience of Malaysia in elaboration of national annexes to Eurocodes. And it is Professor Azlan Adnan from the Malaysia University of Technology. I had the pleasure to meet Professor Azlan earlier this year when we first started discussing about the JRC and DP's database and their benefits. So it is a pleasure to have him today with us and giving us this presentation.
Okay, thank you, Dr. Adnan from JRC. And I would like to also thank eReady as the organizer for inviting me to share with you some of the progress that we have done in terms of the development of our Eurocode, especially on the earthquake for the bridges. And I would also welcome all our friends from ASEAN countries. It seems all of them are here today. Thank you very much to be here. And on behalf of Jabatan Standard Malaysia or Department of Standard Malaysia, we thank you all for this opportunity. I have with me my colleagues back there, Professor Jeffrey, the Deputy President of Institution of Engineers Malaysia, Professor, and Dr. Guna, the council members of IEM, and we have also Dr. Loh, one of our delegates from Malaysia. So it's nice meeting all of you today. We don't have chance yet to talk, to chat with each other of what we have done. So I think in this session, I will try to elaborate what we are doing here in Malaysia. So in terms of the ASEAN case study, Malaysian experience, I will share with you the development of Malaysian National Annex for Eurocode 8, Design of Structures for Earthquake Resistance, Part 2, Bridges. So we have done on the Part 1 for the buildings. So this is the latest progress of what we are doing, the continuation of that. Okay, so I will divide my talk into 4 sections: introduction, the development, highlights of some of the technical terms in this code, and how can we go forward with this. So I hope I have enough time with this 30 minutes or 25 minutes. On the introduction part, some of the history or background of this Eurocode development. As you all know, Malaysia is a part of Commonwealth countries together with Singapore and Brunei. So we have been using British standards for structure design since the British colonial days. So, but when UK in the 2010 switched to BSEN from British standard, so we don't have any choice that we have to follow. So even though there are other codes available, but we want it to be continuous, so and consistent with what we have done before. So in the year 2004, IEM position paper on concrete design standards has been submitted, and we have concluded that Malaysia will switch from BS standard, British standard, to Eurocodes. So it is in line with the UK decisions. So from there on, IEM is chairing most of the technical communities on the Eurocode 0, 1, and 2 for concrete, 3 for steel, and we have, sorry, it is not EC4, should be EC7, yeah? and 8. Okay. The 7, I think IEM is technical committee members. So as you all know, there are many parts of Eurocodes. We have like 0 to 9 for the first generation Eurocode, and we're going to have more, I think, for the second one. And Malaysia has gone through 0, 1, 2, 3, and 7, and now on 8. That's what I'm involved with a lot of them for part 1 and part 2. Well, why we focus also on earthquake? It is a bless that we changed to Eurocode because British Standard doesn't have any requirement for earthquake. So when we move to Eurocode, it is easier on our part to develop. We just adapt and adopt with and then come up with our own national annex. So when earthquake occur in Sabah right now, we had about 5.96 magnitude earthquake. It is quite high for us, for Indonesia, maybe not that so, but it is the first experience that we had a high intensity of earthquake of around 10 to 12% of G, and it has caused a lot of damage to our structures in Sabah right now. As you can see, there are in the police department, staff quarters, there were cracks everywhere on the structures, on the joints and columns. And most the domes tilted, and they have to demolish these most due to this structural failure. And then even the school in Ranau, most of the school, we have a lot, I think more than 30 school, has the same kind of damage everywhere because they are designing with weak column, strong beam. So for earthquake, we should design for strong column, weak beams. So, and we have slight collapse on one of the resort area in Mount Kinabalu. So these are, I think, the first time that we face, failure, damage to our structures. So why this happened? As you all know, the Pacific Ring of Fire is around the intraplate when the plate tectonic collide with each other, as you can see here, and mostly Indonesia, Philippines, and so on. But it seems like before we thought we are safe. If you look at here, we are just surrounded by all this earthquake. But then, if you look at on the right, the USG has come out with a zone of ring of fire. So if you look at it, we are in the zone now. Malaysia, Peninsula, Sabah, Sarawak, Borneo Islands, and some part of the area, we are already in the Pacific of ring of fire. So that made us, really concerned about that. And then the other thing is that not only interplate, but we have also activities intraplate, inside the plate of the land of our country. Like in this article of earthquake of stable continental regions, prepared by Electric Power Research Institute in the US, they have published this document, and it shows that if you look at this, Malaysia, which is in this dotted region, or they call it stipple, we are actually in the active intraplate area. So we are no more in a stable continent that we have thought before. We are in the active intraplate. So that's why we are really concerned about earthquake. Then we expect maybe there will be more earthquake in Malaysia, not only in Sabah and Sarawak, but also in the Peninsular Malaysia. As you can see, like Kuala Lumpur is a very developed city, and we have now a lot of high-rise building. If you can see here, we have Petronas Twin Tower, the KL Tower. We have new high-rise building now, the TRX, Tun Razak Exchange, 108 floors, and the highest now in Malaysia, and probably the second now in the world. It's the Merdeka 118. If you look at the articles, so KL, generate 37% of GDP, contributing about 263 billion to GNI, to our country. And this greater KL region is the prosperous core and the administrative axis of Malaysia's economic growth. So it is very important that we, design our structure safely. And as you can see now, Merdeka 118, which is located now in KL, is the second highest building now in the world. Okay, and also not only buildings, we now have bridges. We have constructed a lot of LRT, light rail transit, and MRT too, like Singapore, a lot of them. As you can see here, the bridges is not just only one level, it goes to up 4 to 5 levels, just like buildings now, as you can see here. So it's very critical. Now the bridge should also be designed for earthquake. So if you look at this scenario, if we want to design for earthquake, we have to look at what are the active faults around us. So these are the active faults that we had. And some of the earthquake that had happened in Peninsular Malaysia, as you can see here. We have, right in KL, we do have some earthquake a little bit in the northern part of KL, about 20 kilometers away in the area of what we call Bukit Tinggi. These are active area, and we thought this could, ignite some of the bigger earthquake later on. So we have to be prepared for that. As you can see here, the faults not only on the northern part, it is also inside KL area, but we don't know yet whether it is active or not. That is the challenge in terms of the geological aspect of it. So if you look at Turkey, we learned from that in the year 2000, just this year, 2023, 6 February, we have had earthquakes there, and you can see the collapse of the buildings, and more than 57,000 people died due to that. So it's a big, event. And after that event in Turkey, people start to ask again, what is our condition in Malaysia? So if you look at newspaper, in the Star, 9 May 2023, they are asking now, is Malaysia prepared to deal with earthquakes? So I was asked in this and give some explanation to the press. And I was saying that we have been practicing this since the year 2017. And in another article in the Malaysian Reserve, and I have highlighted that we have used seismic design guidelines of MSEN 1998. So I am also promoting Eurocode here, part 1, and it should be regulated through Uniform Building Bylaw. So that's another problem that we have. We may have the guidelines, but what about the implementation and the regulation? So in terms of the development, we are quite surprised when I check again in the year 1984, our uniform building bylaws has already included these seismic forces. So by right, all the professional engineers have to follow this regulation, but there's no implementation, enforcement on this. And they also give guidelines on the existing buildings. What should we do? So in the Eurocode 8 itself, we have 6 parts. So we have already completed the part 1 on the general rules, seismic action, rules of building. And now we are going towards the bridges. It's just the right time for us. So what are the documents that we need? So I would like just to show you. Maybe some of you have no idea how it looks like. That is a British standard. So we follow British standard, BSEN, and then we just change it to MSEN. So this is the document. So you don't have any idea how thick the book is. It's just like this, not that thick, around 200, 300 pages, something like that. You know, you just change the front page for this one. This is the main document, the main frame. So a lot of things fall down. And this is the Malaysian annex. See, very thin, just about 50 pages. So I think it's no problem for us to develop. So we follow the format of British Standard. It's quite easy because we just put down the table. What are the UK the Eurocode recommendation, and on the right side we put our recommendation. So I think it's not that difficult, and it is very systematic. I think we just deal with the national annex and change whatever we want, but we need a little bit of study. I will show you how we do it. Okay, for the bridges, our research group, there are a few universities involved in this development. I'm leading this group under UTM, University Technology Malaysia, and we have other universities involved, including Malaysia Rubber Board. The work started in August 2021 and has to finish this year. So we have completed itself. Again, I'm showing you, this is just the right time that we have got the draft final reports for that national annex. In fact, we are going to present it on Thursday to the reviewers. So it is about 1.5 years project, and we need to come up with this national annex. So we will use the same format as BSEN2. And the methodology, first, of course, we need to know what are the NDPs inside the EN. Okay, that is the first step. And then the literature, we need to understand the terms and the values. So these are the most challenging part on our side, because technically we need to understand each one of them, NDPs. You have to go to do literature study, review, and so on. And the challenge to get the values, and then later we need to compare with other NDPs, with UK, EU countries, and other countries. And at this stage earlier, we have problem because we cannot get access to the NDPs of other country in the Europe. So I just contact one of the persons in, I think, EASS, Mr. Pierre at that time, EASS. And then they recommend Mr. Aldo, I think. And then Mr. Aldo bring me to Mina, and then we start to talk. And he recommends Dr. Prof. Roberto and also Dr. Adnan. So from there, we start with the meeting on how to go about it until we get the permission to get access to the database. So this is the most important part of our research. Now we almost, solve our problem because we can get access to the database, so we can see what other country in the European countries has done, and that then it is easier for us to validate whatever values that we suggested. So those are the website, and we can get access to the even UK, EU countries, and also the national annex, the NDP, meaning you can get access every country national annex in there. So I think we have about 30 to 40 countries from there. So I have about 5 minutes, yeah. So these are the NDPs that we have. So there are sections that we divided them to: basic requirement, seismic action on the section 3, and 4, analysis, chapter 5, strength verification, and we have detailing and bridges with seismic isolation. So those are the 6 items. And what we did, we divide them into groups led by a few universities, like for section 234 or chapter 234, led by me and some other members from other universities, and including UMS, University of Malaysia Sabah. And then we have other chapters led by Defence University, University of Science, and Malaysia Rubber Board. So it's important to get Malaysia Rubber Board, the research institution of rubber, for the seismic isolation because we use rubber for that. So these are the groups. Then we put the timeline or the Gantt chart for each of them and how can we achieve every NDPs in there. So this, and then we have milestones. So we have to submit reports at each stages of the study. So we also collaborate with industries. I think these are important. They are the bridge professional, well known in Malaysia, from SMAC, Mr. Baskaran, Walter from GNP Bridge, and then from Perunding ZAR, then from Desaru Expressway Bridge owner, and then from KL Consult. So we have got feedback from them, how it can be implemented, what are the problems if we implement. So these are the workshops that we have done previously. All the members and each of our collaborators, we have some certificate for them. So the first stage that I say the method is to know what are the NDPs. So we make it simple. What are the NDPs? And then what does it mean? In this case, the fault. Does the fault means? The active fault. So there are definition on the active faults, which is it has to be within 11,000 years still active with the movement of a plate of about 1 millimeter per year. So you can decide also yourself, if you have studies on that, active or not, how many years that you expect the length of, duration of earthquake that can be determined as active fault. So, but this is like scientific studies. Everybody accept this 11,000 years, so we just do it. So as you can see, most of this NDP is acceptable for us because this is based on research everywhere. It's almost the same, but only it involves geography, geological. Then we have to do ourselves. Okay, and then we go through maybe I can share some of the steps that we've gone through in the database. When we get access to the database, this is the websites. You have to put in your password in here that will be given. And then if you look at here, these are the list of the code. For me, I'm interested in bridges. So we have Eurocode 81998 and that. Then we just choose bridges. From there, you can see all the NDPs, so the parameters, and the country, like Malaysia here. You can choose all the countries. So we are included here, but we have not submitted yet the document. So we'll be sending it later. But if you go to UK, you can select up here as UK, and then you will see all the decision that they have made on this NDP, on the parameter on the side. So you can just click and you can see what are their decisions over here. So from there, you can collect all this data and you can make comparison. And in fact, not only that, you can get the NDP through the queries. There is a tab here, says query. You can get some of the document they submitted, like in this example. You can get the national annex of each country and you can download. So that is very helpful. So what we did, we go through from one country to another. It's around 41. I noticed 41 countries. So we make comparison here for each NDP, for each country, like here, Belgium. What are their decisions for each NDP? So those are the process that we are going through. I think this is not difficult. We can always share again the details on how to do it with all of you who are interested. Okay, since we have just 2 more minutes, I would just highlight some of the important design issues that we face. First, it's good that if we have the background of the applicability of the design code, the design criteria, what are the classes and behavior. So these are the 4 main terms that we thought is important in bridge design. So it's good because why? In Eurocode, they mention to you what is this code for. Like in this case, it says it is for columns in banding, and it is applied for bridges of cable stayed and arch bridge also. But it's not included does not include the suspension bridge, timber masonry mover bridge. So it's good for us as engineer to know right away that which bridge can we use for this code. It just tell you all that right away. So the next thing is in terms of design for earthquake, it's very important to know what are the return period. So that's number one, return period. They mentioned in Eurocode, it is about 475 or 500 years. So it's no more argument, but you can still change if you want, but that's the guidelines. So the main things that we have to come up with in earthquake is to come up with the seismic hazard map. That's number one, because it will decide whether your building should be designed or not. So that's what we did in the part one, because this is in the part one job, but we have to still refer to that, and we have to come out the response spectra. The good thing, I'm sure everybody, professional engineers, they want to know whether they have to design or not. So if you can tell them that your zone is in zone 0, which is in between 0 to 4% of G area, then you don't need to design. That's another thing that, already solved their problem. And then we have zone 1. Zone 1 is in between 4% and 8%. This one you have to design, but there is no detailing requirement, extra detailing requirement. Other than that, there will be another level. So I tried to compare the Uniform Building Code of United States, 1994, with Eurocode. And zone 0, we can say it is 0 to 4, 1 is 4 to 8, and the rest is 8, 15, and so on. So in Eurocode, they have decided up to this level, and the rest we try to determine ourselves. So that's the magnitude related to that. So in Malaysia, very quickly, I want to share with you, these are the maps that we got. So some spots of the country has the high zone compared to the others. So just about a few percent of the area. So this is very important that you have to establish Sabah and also Sarawak. You have got that map, then we can decide. Here you can see zone 0, 45% of area in Peninsula doesn't need to design because they are in zone 0. Sabah 30% and Sarawak 70%. So not everywhere we have to design because many people scared. And they say, oh, when we implement this, everybody has to design. So no, it has to be according to the map. So this is response spectra. I go quickly. Importance factor that we should look at and the behavior factor. So let's look at the way forward. So I thought that in earthquake community or design, we should have a unified seismic hazard map for ASEAN country. So since we have Indonesia already have it, Malaysia, then we have Thailand, we can just merge. Not necessarily we do it together, we can do it separately, but then we try to unify all of them. Number 2, we can establish technical committee for Eurocode design for ASEAN countries so that we can learn from each other. And number 3, we hope that we can be involved as ASEAN country members in the technical committee at European level, because this is important for us to know how do we get all those values. And this is the one, my initial work, to combine all the maps from other countries that involving Indonesia, even I have here Vietnam and Philippines. We try to put it together. Later, maybe we can make it better for all of us. I think with that, thank you very much for your attention, and I welcome any questions.